Okay, finally, another recording. All right, so this is going to be 4.7 antiderivatives. Basically, if a function is continuous on some interval, you can find that function's derivative. As well, you can find that function's antiderivative on that same interval. So the way we do that is we use the integral symbol of a function. So right here. So we use the symbol, the integral of f of x dx, called the indefinite integral, to represent the family of all antiderivatives. And we write the integral of f of x dx is equal to capital F of x plus some constant c. This is only true if the derivative of the antiderivative is equal to the original function f of x. So essentially, the derivative and the antiderivative will cancel out and get you back to the original problem, which means that is one way to check your work. And I'll show you what I'm talking about. Okay, the curvy symbol is called the integral sign. The function inside is called the integrand. The symbol dx tells us what we are finding the antiderivative with respect to. So if it's x, it'll be dx. If it's t, dt, on and on and on, whatever symbol you want. And c is called the arbitrary constant. It's the constant of integration. So we always add the constant in there, plus c, no matter what. Because who knows if the original function had a constant? Well, that stays, that c will take its place. Okay, so that is the setup to find an antiderivative. Next are formulas we will be using today. Number one is the most popular. It is called the power rule. So if x to any power of n dx will be equal to x to the n plus 1 over n plus 1 plus c. So for derivatives, we take 1 away. For antiderivatives, we add that 1 back. So number 1 is the most popular rule. That is the power rule for antiderivatives. Okay, well 2, the integral of e to the x is, guess what? E to the x plus the constant of integration. The integral of 1 over x is the natural log of the absolute value of x plus c. 4 is the coefficient or constant rule, which means if you have a coefficient times a function f of x, all you have to do is take that coefficient and move it to the outside. We've done it for limits, we've done it for derivatives, so why can't we do it for antiderivatives? 5 says the integral can be split over multiple functions, over addition and subtraction. So the integral of f of x plus or minus g of x is equal to the integral of f of x plus or minus the integral of g of x. And depending how many functions, depends how, will show you, we'll tell you how many integrals you'll have. So if you have 3 functions inside the integral, you have 3 integrals. All right, 6, this is the constant rule, the integral of k dx. So if you're taking the integral of just a number, just a constant, then the antiderivative is kx plus c. That's it. You just add on that variable, kx plus c. Okay, the antiderivative of cosine is sine. The antiderivative of sine is negative cosine. The antiderivative of secant squared is tangent. The antiderivative of secant x tangent x is secant x. And then the antiderivative of 1 over the square root of 1 minus x squared is the inverse sine of x. And the integral of 1 over 1 plus x squared, the antiderivative of that is the inverse tangent of x. Okay. Whew. So those are all the formulas we'll be using today. Okay, so let's get started. Find the indefinite integrals. So we want to find the antiderivative of 7. 7 is a constant, so this will use that constant rule above, which means that my antiderivative is just 7x plus c. That's it. Nothing to it. That's it. That was the constant rule. Okay. How do you check your work? Well, take the derivative. What's the derivative of 7x? The derivative of 7x is, I'll say f prime. The derivative of 7x is 7. What's the derivative of any constant? 0. So we end up with 7, which is the original function inside the integral. That's it. The way to check your work is take the derivative. That's it. Okay. 2. Integral of 8x dx. Okay, so what we're going to do here is use that coefficient rule and take that 8, move it to the outside. So you'll get 8 times the integral of x dx. And now we're going to use the most popular rule on this. We are going to use the power rule because the power on this x is 1. So this will become 8 times, bracket for neatness, and I'll show you how the power rule works, x to the 1 plus 1 over 1 plus 1. That's what we're doing, power rule. Clean it up. 8 times x squared over 2. Multiply the 8 in there, and you'll get 4x squared plus c. As in, si, senor. Okay, and that's it. How do you check your work? You take the derivative. What is the derivative of 4x squared? 8x. That's the derivative. So the derivative undoes the antiderivative. So that's how you check your work. And of course, the derivative of any constant is 0. So there we go. There's our 8x. All right, not bad. 3. Let's do the same thing. Just like above. 3. Pull the 9 out first. Nine times the integral of x squared dx. Then apply the power rule, the most popular rule. 9 bracket. I'll show you how it works again. X to the 2 plus 1 over 2 plus 1. And then 9 times x cubed over 3. Multiply the 9 in there. 3x cubed plus c. There it is. What's the derivative of 3x cubed? 9x squared. What's the derivative of c? A constant? 0. Not bad, guys. Antiderivatives are fun until you get to Cal 2. Then they're even more fun. Okay, let's keep moving. All right. Okay, x to the negative 3. Once again, power rule. I'll get x to the, now you know how power rule works, so let's get through this. Negative 3 plus the 1 gives me x to the negative 2 over negative 2. And then I'll say plus c. We can clean this up one more time. And I can make this negative 1 over 2x squared plus c. That's it. No more to it. That was easy. Where's 5? Oh, guess I need all that room, huh? All right, 5. We'll definitely need room on this one. All right, 5. First thing, take the 10 out. And then times the integral of x to the 3/2 dx. Now, once again, the most popular rule, power rule. And since it's a fraction, I'll work it through step by step with y'all. So first up, 10, bracket for neatness, x to the 3/2 plus 1 over 3/2 plus 1. Close that. Okay, well, you get 10 times, what's 3/2 plus 1? You change that into 2 over 2, so that should be x to the 5/2 over 5/2. And then we can't keep this fraction in the denominator, so we will reciprocate it, or what you guys like to say is flip. So we flip it. Now, who do they want? Flip, flip. All right. So you flip it. The 2 comes to the numerator. 2x to the 5/2 over 5. Okay. And then multiply that 10 in there. And I'll get 20 over 5 or just 4, right? So you get 20 over 5, or you'll just get 4x to the 5/2 plus c. Done. That's it. Hey, look at that. Oh, we didn't need all the room. Okay. Normally when I write on the actual whiteboard, I would take up more room, but you get it. Okay, 6. We've got some manipulating to do before we begin, which means we have to rewrite those radicals, right? Just like for derivatives, we always have to rewrite the radicals. So this would become the integral of 3x to the 1/2 minus 2x to the 1/3 dx. All right, 3x to the 1/2 minus 2x to the 1/3 dx. There's 2 terms inside the parentheses, so we can actually use that, that property above where we can split it over multiple integrals. So since there's 2 terms inside, we'll have 2 integrals. And maybe I'll make use of my space here. Let's see. This will become the integral of 3x to the 1/2 dx minus the integral of 2x to the 1/3 dx. Oops. Dx. Okay. And now before we continue, pull out the 3, pull out the 2. 3 times the integral of x to the 1/2 dx minus 2 times the integral of x to the 1/3 dx. We are now ready for the antiderivatives, and on x to the 1/2 and x to the 1/3, we will use power rule on those. Oof, lovely fraction work coming up, right? 3 bracket power rule. X to the 1/2 plus 1 over 1/2 plus 1 minus 2 times x to the 1/3 plus 1 over 1/3 plus 1. Okay, not bad. Clean it up. And we get 3 times x to the 3/2 over 3/2 minus 2 times x to the 4/3 over 4/3. How am I on room? Oh, we are perfect. Okay, still some more to go. All right. And remember what to do with these fractions. We will flip, right? We will flip them. Three times 2x to the 3/2 over 3 minus 2 times 3x to the 4/3 over 4. All right, and we're almost done. Cancel. 3's cancel. We get just 2x to the 3/2 minus that 2 becomes a 1, that 4 becomes a 2, minus 3/2 x to the 4/3 plus c. There it is. All right, and nothing else. No need to rewrite it either. That's perfect enough. Whew, all right. Okay, so let's keep going. Oh, here comes a tough one. Too tough here, okay? All right, so take the 16 out, and we get the integral of e to the u du, and you'll get 16. Guess what the antiderivative of e to the u is? It is still e to the u. So you'll get 16 e to the u plus c. That's it. Beautiful. Okay. Look at us go. Okay. Number 8, 2 plus x squared over 1 plus x squared. All right. So we don't know how to do integrals by substitution yet, and you never will until you go to Cal 2. So with that being said, we have to algebraically manipulate this integral. And I'm going to scroll back to the very first page to see what formula looks most like this question. So 2 plus x squared over 1 plus x squared. Let's go back, way back. Okay. Oh, look at that. Number 12. the integral of 1 over 1 plus x squared is equal to the inverse tangent of x plus c. So number 12 is going to be the formula we want. So back down. I'll write that above. So we want this one to look like 1 over 1 plus x squared. Oops. Equal to the inverse tangent of x plus c. Okay, so how do we get this to look like that above? All right, well, there's multiple options, right? So one, we know we can split up fractions. So could I make this into, well, right? I mean, I know how to do it. I just want to make you think a bit. So first thing, we'll split it into two fractions, right? You can make this 2 over 1 plus x squared and x squared over 1 plus x squared. But then we run into an issue. None of these look like that yet, right? How do we make it look like that? And this does require a little out-of-the-box manipulation, but we're not doing anything wrong, right? Because we're in Cal 1. We're beginner mathematicians right now, right? We're almost advanced. When you get to Cal 2 and Cal 3, you are expert mathematician, okay? Right now, you just know algebra. Well, maybe, okay? All right, so what we want to do is look at this 2. Well, let's go ahead and split this 2 into two numbers that we know. 1.5 and 0.5. I'm just kidding. Split it into 1 and 1. You're like, what is wrong with him today? It's like, I had my cup of coffee like 5 minutes ago. So, all right. So that means if I split it into 1 plus 1 over 1 plus x squared plus x squared over 1 plus x. Don't mind the sloppy notation right now, because I'm going to erase all of this and come back to the proper notation, which means that now 1 plus 1 means I have 2 terms in my numerator, which means I can split this fraction into 2 more fractions. I can make this into 1 over 1 plus x squared plus 1 over 1 plus x squared plus x squared over 1 plus x squared. Okay, well, according to our formula above, this checks out, this checks out, this does not check out. So we have one more thing to think of, because we have to take care of this last fraction. How do we get rid of this x squared over 1 plus x squared? Well, let's go ahead and combine these two and watch the magic. You'll get 1 over 1 plus x squared plus 1 plus x squared over 1 plus x squared, which means that 1 plus x squared over 1 plus x squared is just 1. Oh my goodness, right? So here's what we end up with. 1 over 1 plus x squared plus 1, where this checks out, and this would just become x once we take the antiderivative. So, like I said, I'm gonna get rid of all this now and do proper notation, because now we have what we want. So this is going to become the integral of 1 over 1 plus x squared plus 1 dx. There we go. Okay, and now let's go ahead, split it into two integrals. The integral of 1 over 1 plus x squared dx plus the integral of 1 dx. Okay. By the above formula, 1 over 1 plus x squared, the integral of 1 over x squared, 1 over 1 plus x squared dx becomes the inverse tangent of x plus the integral of 1 is the antiderivative of x plus the constant of integration c. There it is. That's it. So sometimes we have to think a little out of the box, right? All right. Tricky, tricky. Okay. Number 9. If the second derivative is 20x squared, x cubed minus 12x squared plus 6x, find f. Okay. So this means that we're going to have to find the antiderivative twice. So this means the first thing we must look for is f prime. So we can label this in steps. Let's say A. Find f prime. And you'll get f prime of x is going to be equal to the integral of f double prime of x dx. Because if we take the antiderivative of f double prime, we will get f prime. Okay, which means that you get the integral of 20x cubed minus 12x squared plus 6x dx. Okay, now let's find the antiderivatives. We know we can split this into 3 integrals, but we don't have to anymore. Those days are over. We can now shortcut this because on x cubed, x squared, and x, we are going to be using the most popular rule on all 3 of those. We will be using power rule. Power rule on all 3. So we know how the properties work, and we know how to shortcut now. So what we're going to get is 20 times power rule on x cubed, x to the 4th over 4, minus 12 times power rule on x squared, x cubed over 3, plus 6 times power rule on that x, x squared over 2. Cleanup time. 20 times x to the 4th over 4, 5x to the 4th, minus 4x cubed, plus 3x squared, and don't forget the c. This is f prime of x. Beautiful. Now, let's find, I got a lot of room. Now let's find f of x. So B. Find f. And f of x is going to be equal to the integral of f prime of x dx. Okay, which means that you get the integral of 5x to the fourth minus 4x cubed plus 3x squared plus c dx. Okay. And now, once again, we are ready to find the antiderivative, and it's going to be power rule on the first three terms, and then the constant rule on the last term, because c is our constant. So here we go. 5 times power rule on x to the fourth. X to the fifth over 5 minus 4 times power rule on x cubed plus 3 times power rule on x squared plus the constant rule on c. So the antiderivative of c is cx. And don't forget to add another constant of integration, which we will label as d. Why not? Okay. So cancel, cancel. X to the fifth minus x to the fourth plus x cubed plus cx plus d. This is f of x. And that's it. Okay. Not bad. And if you took the derivative of f of x, that'd give you the f prime of x, which would then take another derivative, that'd give you to f double prime of x. So that's how you would check your work. Okay, moving on. 10, I will skip. It's just like the one above, except you're actually solving for C and D this time. Not bad. It's giving you the numbers to plug in. Let's move on. I'll leave that up to you. All right. Okay, number 11. The integral of 5x times 1 minus x. So we don't know how to do integral by parts or anything like that. So what we're going to do is, again, algebraically manipulate. So all you have to do is distribute the 5x. Distribute the 5x. Okay. So this means that we'll have the integral of 5x minus 5x squared dx. Okay, 5x minus 5x squared dx. Two terms, which means you could split it into two integrals, but we don't have to. This means that we can already find the antiderivative. It's already set up for us. So this means that we'll start with 5x. The 5 will wait outside, and now we want the antiderivative of x, which we'll use power rule, which becomes x squared over 2 minus 5 times power rule at x squared, x cubed over 3. Clean it up, and we're done. 5 halves x squared minus 5 thirds x cubed plus c. That's it. As good as it gets. All right, perfect. So there's 11. Moving on to 12. Okay, definitely some manipulation on this one. You're going to have to rewrite the square root of u. Rewrite the radical like we always do. Antiderivative, derivative, doesn't matter. Always have to rewrite the radical. So we get the integral of du over u to the 1/2. Then take u to the 1/2, flip it to the numerator. You'll get the integral of u to the negative 1/2 du. And now we are ready for power rule. Always the most popular one, power rule. So you'll get u to the negative 1/2 plus 1 over negative 1/2 plus 1. You get u to the 1/2 over 1/2. Now remember what to do with this. Who they want? They want flip. So flip it, and you'll get 2u to the 1/2 plus c. That's it. Nothing more. 2u to the 1/2 plus c. You can change it to 2 square root of u if you want. No need to. Okay. All right. So (13). Again, don't know how to find the antiderivative in this form, but we can algebraically manipulate. We see that there are 2 terms over the same denominator, which means we can split it into 2 fractions, right? Split it into 2 fractions, which will give me the integral of 2x to the 4th over x cubed minus x over x cubed dx. Okay, simplify some more, cancel out some powers, and we'll get the integral of 2x to the 4th over x cubed, that is 2x minus x over x cubed. That becomes 1 over x squared, which becomes x to the negative 2, right? 1 over x squared. So this means I'll get 2x minus x to the negative 2 dx. I see my face is in the way. There you go. 1 over x squared, x to the negative 2. Okay. This means that we're ready to find the antiderivative. So first up is 2x. The 2 remains on the outside, and you will power rule the x, which means you'll get x squared over 2 minus power rule x to the negative 2. You should get x to the negative 1 over negative 1. Clean up. Your 2's will cancel, and you get x squared. And then here, negative over negative makes positive. So x squared plus x to the negative 1 plus c. That's it. I mean, another way to handle it, you'll get the same thing, is we did it for derivatives. If we didn't like splitting it into two fractions, we'll take x cubed, flip it to the top. X to the negative 3 times 2x to the 4th minus x. Distribute, and you'll get 2x minus x to the negative 2. That seemed a lot faster. Maybe we'll do that on the next one. All right. All right. Again. All right. So I think we all agree that that other method was faster, so let's do that. So here you'll get the integral of x to the negative 4 times x to the 5th minus 2x dx. Distribute that x to the negative 4, and you'll get the integral of x minus 2x to the negative 3 dx. Not bad. That's a lot faster, right? That'd be x and then 2 over x cubed, 2x and negative 3, which means that this is now ready for power rule. The antiderivative of x is x squared over 2 minus 2 times the antiderivative of x to the negative 3 by power rule is going to be x to the negative 2 over negative 2. Did I forget my c on the last one? No. All right, good. Okay. Clean up, make it look pretty. You get 1/2 x squared, negative 2 over negative 2, negative 2, negative 2, negative over negative makes positive, and you get 1/2 x squared plus x to the negative 2 plus c. Done. That's it. Done. All right. Let's do it again. All right. So flip that up. X to the negative 2 times x squared e to the x minus 2x dx. Distribute it in. Your x squared and the first one will cancel. So you're just left with the integral of e to the x minus 2x to the negative 1 dx. Okay. So here's going to be a word of caution. I need to circle that better. For x to the negative 1. So if you ever get x to the negative 1, you always must write it as 1 over x. And I'll show you why. So here is caution, right? Caution. Cuidado. Okay. So if you did the integral of x to the negative 1 dx, you would use power rule on this, right? You would use power rule, which means you get x to the negative 1 plus 1 over negative 1 plus 1. this would give you, oops, I was already thinking ahead, like usual. -1 plus 1. This would give you x to the 0th over 0, which means that anything to the 0th power is 1. If you said 0, get out. Okay, so you would get 1 over 0, which is undefined. And we don't want that. So what we have to use here is that the correct way to write this is always as 1 over x, right? We always want to write it as 1 over x. Here, we'll do the right way. So if you ever get the integral of x to the -1 dx, always write it as the integral of 1 over x dx. Because if you go to the very first page, which let's do it, close your eyes, we'll be there in a second. Scroll, scroll, scroll. Look at number 3. The integral of 1 over x dx is the natural log of the absolute value of x. So if you ever get x to -1, always rewrite it as 1 over x. If you don't, you'll run into that issue we don't want. All right, here we go. We're going back. Whee! Good. Bad. Okay. Let's continue. So the integral of e to the x minus 2 over x dx. There we go. Oh yeah, small little rant here. Let me just go off. Let me go on a tangent for a bit. A lot of you had something like this on your exam. It was like 5x to the -2, and you rewrote it as 1 over 5x squared. That is a no-no, right? That is a no-no, because the only thing that should be flipped is the x, because 5 is not being raised to -2, x is. So, I mean, very simple mistake to make, but it should have been 5 over x squared. That's it, right? If it was 5x to the -2, then yes, this is 5, whoops, this is 1 over 5x squared. Do not make those mistakes. Those are killer. Rant over. Back to a regularly scheduled program. Ugh. Regular schedule, whatever. You get it. Okay. So we are ready for the antiderivative of e to the x, which is, guess what? E to the x. That's it. So we'll get e to the x minus, we want the antiderivative of 2 over x, which means the 2 will wait, and the antiderivative of 1 over x is going to be the natural log of the absolute value of x. And then one final cleanup, e to the x minus 2 natural log absolute value of x plus c. Boom, that's it. Okay, hey, look at that. That is it. Nice, that was 4.7. Okay, I still have some time left, so I guess I can do number 10 for you. With the quickness, let's see. A. Oops. Find f prime. F prime of x is equal to the integral of f double prime of x dx, and you'll get the integral of -2 plus 12x minus 12x squared dx, and we'll get, we are ready for the antiderivative. It's all nice and set up. So we'll start with -2. The antiderivative of -2 is a constant. So -2x plus 12 times power rule on that x squared over 2 minus 12 times power rule on x squared, x cubed over 3 plus c. Equal to -2x, what's this become? Plus 6x squared minus 4x cubed plus c. So this is f prime of x, but they are giving us a little piece of information to help us solve for c. They are giving us that f prime of 0 is 12. That means plug in 0 and set everything equal to 12. So that's what we're going to do here. We're going to say f prime of 0, which means that if I plug in 0, that's 0, that's 0, that's 0. And all I'm left with is c, which means c is equal to 12. Which means that f prime of x is actually -2x plus 6x squared minus 4x cubed plus 12. And if you want to write it in highest power to lowest power, go ahead, because it's all out of whack right now. So maybe I'll do that in the next step. So the next step is find f, find function f. Not f, just find f. There we go. Okay, so function f of x is going to be equal to the integral of f prime of x dx, which is going to be the integral, and I'll do this highest power to lowest power, why not? -4x cubed plus 6x squared minus 2x plus 12 dx. Okay, and then, ooh, I'm actually running out of room. Cool. All right. So with that being said, let me zoom in, need all the space I can get, and I'll have -4 times x to the 4th over 4 plus 6 times x cubed over 3 minus 2 times x squared over 2 plus 12x plus another constant of integration. Okay. Clean it up, and you get negative x to the 4th plus 2x cubed minus x squared plus 12x plus c. This is f of x. Okay. And once again, they give us another piece of information to help us solve for c. They say f of 0 is 4. F of 0 is 4. So plug in 0 and set everything equal to 4. So this means that f of 0, and again, if I plug in 0, 0, 0, 0, 0, you are just left with c. And 4 equals c. Which means f of x is negative x to the 4th plus 2x cubed minus x squared plus 12x plus 4. Done. And there's f of x. Okay, awesome. So that ends our antiderivatives. Yeehaw. So you see a lot of algebraic manipulation, definitely. I'm surprised I didn't have any trig on there, except for the inverse tangent. Lucky you. Okay, that is it.